All right, so now for these, we're trying to figure out how many solutions they'll have. Okay, so let me show you how you can do this without having to do a whole bunch of work. Look at this. Okay, this is a different slope, right?
Right.
How many solutions do you think it'll have? One. Different slopes will have one. Okay? That's not a very good one. One. Does that make sense? Now, why? How do I know that's for certain, though? Yeah, I can do the algebra, but I'm trying to show you. But there's a clue in there. I could definitely do the algebra, but there's a clue in there. And the clue is that if it has different slopes, then it has different rates of change. And since they're straight lines, they're probably going to cross somewhere, right? Does that make sense to you guys? Okay, so let's, that's the main thing I want you guys to think about. What about the next one? Well, how do we know? We might have to do a little bit of algebra on this one. Well, hold on. Let's back up a second. I just reread the question. Hold on a second. Yeah, I'm not saying that you're wrong. I just reread the question. It is an ask. Well, I never read the question. This has one solution, and then it says, what would the equation be? Well, in this case, if it's one solution, the equation will be true. It wants to know if it'll be true or false. Now, on this one, we got to do a little bit of math. So if I multiply this through, I'm going to get 12x. 3 times 3 is a positive 9, right? And then we have minus 2 equals 12x plus 7. Now, when I combine like terms, I'm going to get 12x plus 7 equals 12x plus 7. Now, that will always be true. And now back to how many solutions will that have? How many will that have? Yeah, so we're just going to say many solutions, infinitely many solutions. And you guys know that when I write down SOLN, that's my little shorthand for solutions. It's not mine, it's everybody's. Now, what about number 4? We look at the slope. And when I say we look at the slope, you have to make sure that it's in the form y equals mx plus b. Okay, over here it wasn't quite there yet, but if you notice, Mr. Adams made it look like that. Over here it is. It is like that. So my slope is the same, right? But different intercepts. When I have the same slope but different intercepts, that means they're parallel lines. That's the word parallel. So what do you know about parallel lines? They're never going to intersect, and this will be false. Fallacy. Sounds weird to me, but whatever. So it's false, so there are no solutions. What did I say? Fallacy? Fallacy? Because I was thinking false. I know, it's funny. People, if I misspeak, because sometimes I misspeak because I'm thinking it in my brain. The whole emoji versus emojicon.
Emoticon.
Well, let me see what I'm saying. So this supports my case. People really want to catch me doing something wrong. What bothers you? No, they only do it to me.
No.
Well, quit judging each other. Anyways, do you guys have, does this make sense? No, not at all. So let me recap. So I said, does this make sense? And one of my students goes. So what we're doing here is, because they have, so let's recap real quick. Because they have different slopes, that means that when I graph them, because it has different slopes and different y-intercepts, that when I graph it, and I'm not sure how or exactly where, I don't need to know how or exactly where, that at some point the lines are going to cross, okay? I don't need to know where they're going to cross. Actually, this would be a little bit better of a... I don't know where they're going to cross, but they're going to cross somewhere, right? So that's going to be one solution, okay? So if I graph these two lines wherever they are, actually, that's not necessarily an accurate. Let me try to make it a little more accurate, because I know somebody will get frustrated. So 2x plus 1, so this will probably cross like this. And then 5x minus 8 is going to cross here, but it'll have a much steeper. And I don't know where they're going to cross, but they're going to cross somewhere here. So if I go to graph these two lines, they're going to cross at some point. Where they cross is the one solution. They only cross once. Does that make sense? What is the part that's... Is it the fact that they intersect once, or the fact that I know how the graph kind of looks? And that they have different slopes? Like, what's the first part that you don't feel confident about? Everything. Well, let's start with one thing, and then we can try to figure that out. So when I say that m is the slope, that's the steepness of the line. So I drew this one in blue, which has a slope of 2, which means I'm going to go up 2 over 1, up 2 over 1. When I drew the red line, I was kind of mocking this one, and that's a steeper slope. So that means I'm going to go up 5, then over 1, up 5 over 1. So that's going to be steeper. So because I know one will be angled one way and the other one will be angled another way, I know at some point in time, because if you have two lines that are parallel, the same slope, they never cross. If I have one that's slightly off, at some point in time, they're going to cross. And if they're like this, at some point in time, they're going to cross. Does that make sense? No? We'll talk about it more later. We'll just keep going over it until it does. But basically, if they have different slopes and different y-intercepts, well, the y-intercept doesn't matter as much. If they have different slopes, then it's probably going to cross at least one time graphically. And that's how I know it has one solution, so then it'll be a true statement. This will have a solution that looks like x equals some sort of number. Okay? So when you solve this one, it'll look like this. Now, for number 3, if I go to graph number 3, because they're basically the same equation. When I go to graph this, it's going to have a y-intercept of 7 and a very steep slope. So that graph is going to go like this. But when I go to graph the second part, or the right part of the equation, on the right-hand side of the equal sign, it has the same slope and the same y-intercept. So the lines are literally going to be the same lines right on top of each other. So that one will cross here, it crosses here, it crosses everywhere. And so because the intersection of these 2 points, or these 2 graphs, are the solutions, it's always going to be true. But when you solve this one algebraically, you'll get like 3 equals 3 or 1 equals 1. Okay? But it'll have infinitely many solutions, because no matter what you plug in for x, this side will always equal this side. Okay? Now over here, where it's parallel, with this one, what's going to happen is when I go to graph this, I'm going to have, if I graph this one first, whoops, I got to finish drawing my graph. It's going to have a y-intercept at -9, so somewhere down here I'm going to have a graph that does this, but it has a slope of 3, so it's going to look like that. But then when I go to graph this, it has a y-intercept of positive 5, but the same slope. So it has the same slope, so they're going to be parallel lines, and they never cross. And because they never cross, then there's no solution. And when you go to solve this one, you'll get like 0 equals 14. And that's false. Does that help? No? Okay. Well, it's the first time doing it. We still have a bunch of example problems, okay? So let's do a thumbs up, thumbs down. Thumbs up if that kind of makes sense. Thumbs down if it doesn't make sense. And if you're somewhere in the middle, that's fine too. Okay. Let's keep going.